In this video we're going to be looking at some applications of using vectors. The first one obviously is using bearings and directions and so on. And this happens quite a lot. So you're starting in a place, you're heading in a different direction, and then you're changing your bearing and going, and so therefore we want to know how far you've travelled from your starting point. And if I wanted to go directly from A to C, what bearing would I need to travel at? Alright, so that's the sort of question that we're using vectors. Obviously, we know how to work out the length of a vector. As long as we know the direction of it, then the same process could happen on a grid as well. So, in terms of looking at this, now if we're looking at from 100 from our little north line, so a north line you put a little arrow, so we know that bearing there is 45 degrees, and from our north line here, little arrow, we know that the bearing all the way around there is in fact 285 degrees. Alright, so if we're thinking about this particular angle there, if that continues on that line, that means that this angle here would be 45. That angle there is 180, isn't it? So 180 plus 45 is 225. 285 take 225, that means that this angle in here is 60 degrees. Right, so it's 60 degrees. Now, if I think about this being a triangle, a little bit like this, right, I've got 60 there, I've got 150 there, I've got 120 there, and I want to find this side over here. Well, thinking back to what we did in first semester, we would use a cosine rule. Okay, so x would be equal to the square root of 120 squared plus 150 squared, take 2 times by 120, 150 cosine of 60 degrees. And that would allow me to work out what x was. So that's the first thing I'll do. So calculator, square root, use your bracket there, so it's going to be 150 squared plus 120 squared, take 2 times 150 times 120 times cosine of 60, right, and then close the brackets, and that works out to be 137.5, we'll go all 48, 137.48, 37.48 kilometres. That's how far we've got to travel. Now, I also have to work out the angle as well, don't I? Alright, so I know this side now is 137.48. Alright, I need to know this angle here, we'll call that theta. Alright, so theta associates to that side there, that angle associates to that side there. So we're going to use the sine rule in order to work this out. Alright, so we're going to say, and here is sine theta, corresponding side is 120, equals sine of 60, corresponding side is 137.48. Okay, I'm going to rearrange that a little bit. I'm going to say theta is equal to the inverse sine. I'm going to bring 120 up. 120 sine of 60 all over 137.48. And that will work out my angle theta. Alright, so let's do that. So you can do this one step. 120 times sine of 60. Bracket, divide that by 137.48, and that will give me my answer. So it gives me 49.1 degrees. So theta is equal to 49.1 degrees. Now, if we're going 45 degrees in that direction there, that means this angle in here, this little bit here, has to be 49.1 take 45, which gives me an answer of 4.1 degrees. So I'm 4.1 degrees on the left hand side of 360. So therefore I have to think about my bearing. I'm going to give a bearing. So therefore A to C is, well, we know it's 137.48 kilometres at a bearing of, well, it's going to be 360 take 4.1, which is going to give you 355.9 at 355.9 degrees true, and that will give me my bearing that I need to travel from A to C. That's one example of where you might use that particular vector in a real life example. Alright, and we'll do another video showing you another example. Alright, so I'll just leave this one here and we'll do another video to show you another example.